Labguy here. This is a project update on the Nbtv DissectorCam. I've not made a lot of progress since the last video, but I've learned a lot. I believe that the scanning circuit, which I will cover in a moment, is not putting out enough drive, and so that the scanning of the Desector tube target, if you will, the photosensitive surface, is under scanning, which is limiting the amount of detail we can see. It's making a fairly good picture. I think it can do better. That's one problem. And the second problem is the back focus distance, that is the distance from the back of the lens to the face of the tube in here, is wrong. The camera will not focus out beyond a few inches, but beyond here everything is out of focus. So the back focus distance is wrong. I may be able to correct it without reprinting this front cover, but I will probably end up reprinting the front cover to fix that problem. The scan board is complete as it is and has two sets of circuits. Let's look at those. We have the sync generator right here and the scanning amplifiers right here. The sync generator starts with the crystal oscillator, drives 3 counters, a memory chip, an output latch. Then the signals from the sync generator go to 2 scan ramp generators, which have 3 sets of adjustments. The pots, there's of course a horizontal scan and a vertical scan, or a frame scan and a line scan, whichever you prefer. The first of 3 pots in each circuit sets the current to the ramp generator. The second pot is the scan centering in the deflection yoke, and the third pot is the scan size. S for size, C for centering, I for current. 2 scan amplifiers. All of that lives right here. It's very straightforward right here. Then the scan output of the 2 ramp generator op amps drive the 2 LH0002 high power buffer chips from National Semiconductor. These are extremely obsolete parts. They drive out to the deflection yoke through the wires and return to ground through the 2 power resistors, which develop the feedback voltage back to the op amp to close the loop on that. We'll cover that shortly in the scan circuit deep dive, which I will do next. Looking at the Nbtv DissectorCam scan circuits, you can see that they are remarkably simple and very similar to the scan circuits in the Nbtv Crt Televisor. The initial stage is exactly the same as the Crt Televisor. Frame drive or line drive comes from the sync generator to fire a reset switch consisting of a 2N7000 field effect transistor connected in parallel with a scanning capacitor. For the frame drive, the capacitor is 4.7 microfarads, and for the line drive, it's 150 nanofarads. The frame drive scans 12.5 frames per second. The line drive runs at 400 lines per second. The capacitor is charged up through a current source consisting of a PNP transistor and a Zener diode now. My earlier current sources did not have a diode and depended on the setting of the variable resistor to establish the current. They work well enough, but they have a problem that they are very temperature sensitive. In the case of the Crt Televisor, when you first turn it on for the first 15 to 20 minutes, the image is very small. As the current source warms up, the ramp gets larger and larger, and the picture gets larger and larger until I've aligned it at temperature so that when the unit is warmed up, the picture's the right size. But for the first 10 minutes, the picture's too small. So I fixed that here by using a Zener diode in the current source. The Zener diode has a constant 5.1 volt drop, which goes to ground through the 680K resistor. This puts the base of the transistor at about 7 volts. Then going back up through the base to the emitter of the transistor, we lose 0.65 volts, which puts about 7.5 volts across the 10K and 5K adjustable resistors. This creates a constant voltage drop at that point, and we set the variable resistor to give us a current that makes our capacitor charge up at just the right amount within the either frame scanning period or the line scanning period. The output of the ramp generator goes through the buffering op amp, which buffers the capacitor from the load of the variable resistor. The capacitor, because of the Zener diode now, can only charge to a maximum of 7 volts. This is one of the limiting factors in the scan size problem I mentioned earlier. Coming through the variable resistor, which gives us the ability to adjust the size of the voltage going to the deflection yoke, or more precisely the voltage that will be converted to a current in the deflection yoke. It goes through a gain stage of gain of 2, which consists of the op amp and the LH0002 high current voltage follower. The output of the high current buffer goes through the deflection coil, which has a resistance of 1/2 ohm, which is too low for the amplifier to drive directly. The output of the deflection coil, the return lead, goes to ground through a 24.9 ohm resistor. This establishes a maximum current in the area of around 125 milliamps, which is higher than the amplifier's rated, but seems to work okay. The feedback to the op amp is established from that resistor and is also summed with the voltage of the centering control, which allows us to center the scan on the deflection coil so that the drive to the deflection coil is traveling from minus 100 milliamps to plus 100 milliamps, because it has to sweep the image in the dissector tube both left and right, or up and down. So it scans around a 0 center, and that completes the description of the scan circuits. We'll do a much deeper dive when these circuits are finalized. This is probably not the final design. This concludes the update of the current status of the Nbtv DissectorCam. I'd like to welcome all new subscribers. Thank you for signing up. We get 1 or 2 or 3 new subscribers every day, and we are headed for 3,000 subscribers soon. I don't know, should we have a special event, or should we just go, 3,000 subscribers? But welcome to all new subscribers. Greetings to all of my current subscribers. I want you all to know that you're a special crowd for watching this channel. This channel, I promise you, brings you material you cannot find in any other channel on the web as it relates to vintage television technology. And so thank you for your viewership. I appreciate it. If you feel compelled to leave a thumbs up, that's up to you. Definitely subscribe if you're watching this and you're not subscribed to get further updates. Check out some of my other videos. I admit freely that they are of lower production values, but look beyond that at the information content. You'll find it nowhere else. So, until next time, this is Labguy, out.